Hello everyone, I'm Professor Sahebgouda Patil. I welcome you all for this cloud computing lecture. So in today's session, we'll be talking about cloud virtualization. So in this, we are going to see what is the motivation of the cloud, then brief introduction about virtualization concept. So these topics I'm going to cover in this particular lecture. So first we'll see like what is the motivation or what is a brief introductory about virtualization, that is cloud resource virtualization. So there are three classes of fundamental abstractions, mainly interpreters, memory, and communication links. So these all three classes of fundamental abstractions are very much necessary. So these are very much necessary to describe the operations of a cloud computing or a computing system. So the physical realization of each one of these abstractions, such as we can call it as interpreters or processor. So these processors that transform the information. The role of the interpreter is that it transform the information, transform the information. So next we have the memory. So in that memory, we have primary memory and the secondary memory. So this primary and secondary memory for storing the information. The role of the memory is that storing the information. So this is the second abstraction. The third one we have communication link. The role of the communication link are communication channels that allows different systems to communicate with one another. So there are like many systems will be there. So those systems, they can communicate with one another, using communication link, or you can also call it as a channel, communication channel. So next we have the resource management. So what do you mean by resource management? So here the resource management becomes even more complex. So when it will be complex? It will be complex when resources are oversubscribed. When resources are oversubscribed, then the resource management will be very complex. Another case, that is when users are uncooperative. So in that case also the resource management becomes more complex. So in addition to the external factors for the resource management, so there are some internal factors also affect, such as heterogeneity and the hardware of the system, and we can call it as a software system. So there are like two factors, that is the internal factors that will be affected, such as heterogeneity of the hardware and software system. So this is all about resource management. Then come to the next concept, that is virtualization is a basic tenet of a cloud computing. So how we can say that it is a basic tenet of cloud computing? So this simplifies some of the resource management tasks. So already we know like what is resource management and how it becomes very complex. So virtualization is a basic tenet for the cloud computing. So here we can see an example, that is virtual machine and virtual machine monitor. So these two concepts are there. So virtual machine, what happens? The state of virtual machine running under the virtual machine monitor, can be saved and migrated to another server to balance the load. So in the resource management, we need to balance the load. To balance the load, what we have to do? We have to, like, the state of virtual machine, that is VM, that running under the virtual machine monitor, can be saved and migrated to another server. Then only we can able to balance the load. At the same time, what happens? At the same time, virtualization allows users to operate in environment they are familiar. This is very important. So virtualization, what it allows users to operate in environments they are familiar with, rather than forcing them to idiosyncratic ones. So they must familiar, then only they can able to work with the virtualization concept. So this is the brief introduction about virtualization. We can say that motivation. So move on to next. Next, we have some simulation the interfaces to physical objects. So what are those? So virtualization simulates the interfaces to a physical object by any one of four means. So there are like multiplexing is there, aggregation, emulation, multiplexing, and emulation. So we can see one by one in detail. So what do you mean by multiplexing? Multiplexing means which create multiple virtual objects. So what it does, which create multiple virtual object. So when it create multiple virtual objects from one instance of a physical object, from one instance of a physical object. For example, we have the processor that is multiplexed among a number of process, or we can say threads. Okay, the difference between process and thread, I think you might have studied in the operating system. So the main difference between process and thread is that process, it is a system call, and thread, that is a user call. Okay, thread, it is a lightweight and process is a heavyweight. So this is a general difference between process and thread. So we can consider one of the best example for the multiplexing, that is a processor is multiplexed among a number of processes, or we can say threads. So next we have the aggregation. So what do you mean by aggregation? Aggregation means create one virtual object. So what we are going to do here, we are creating the one virtual object. So one virtual object from multiple physical objects. In case of multiplexing, there will be only one physical object was there. So in case of aggregation, we have the multiple physical objects. So for example, number of physical disks are aggregated into RAID disk. So this is the example for the aggregation. So next we have the emulation. So emulation, it is a construct a virtual object. So emulation, what it does, here we are going to construct virtual object from different types of the physical objects. So in this case, we are going to use the different types of physical object. From this different type of physical object, so we are going to construct a virtual object. For example, a physical disk emulates a random access memory. So this is an example for the emulation. So what happens here? A physical disk which emulates a random access memory. So next we have multiplexing and emulation. So multiplexing and emulation, the best example for this is virtual memory with phasing multiplexes. So I think you might have studied this phasing concept. So virtual memory with phasing multiplexes, real memory and disk and virtual address emulates a real address. So here we are going to use the TCP, that is transmission control protocol. What it does, TCP, which emulates a reliable bit pipe and multiplexes a physical communication channel and processor. So this is the role of the TCP, that is transmission control protocol. So these are four, like we can say four means where virtualization simulates the interfaces to a physical object. So next we have the continuation part of virtualization. So virtualization is a critical aspect of a cloud computing. Virtualization is what? It's a critical aspect of cloud computing, equally important to the providers and as well as the consumers of a cloud services, and plays an important role in. So what is the role of the virtualization which plays important role in? The first one is system security. So how like it provide the system security? System security, which because it allows isolation of a services running on the same hardware. So what happens, which allows isolation, when it allows the isolation of the services running on the same hardware so that it can provide the system security. So next we have the performance and reliability. So performance and reliability, that is because it allows applications to migrate from one platform to another platform. So what happens here, the applications will be migrate. So where to where? From one platform to another platform, the applications are going to migrate. So that is how it can provide the performance and reliability. So next we have the development and management of services offered by a provider, that is a service provider. The last one, performance isolation. So these are the cloud resource virtualization is important for all these aspects. So hope you can understand this. So move on to next, continuation of virtualization. So this chapter is all about the cloud resource virtualization. So virtualization has been used successfully since the late 1950s. So here, a virtual memory based on paging was first implemented on the Atlas computer at the University of Manchester. So the first virtual memory based paging concept that was implemented on the Atlas computer, on the Atlas computers at the University of Manchester in the United Kingdom in 1959. Okay, in this year they have implemented for the first time in a cloud computing environment. VMM, that is virtual machine monitor. Virtual machine monitor runs on the physical hardware and exports the hardware level abstractions to one or more guest operating system. So here we can see the user convenience concept as well. So what do you mean by user convenience? So user convenience is a necessary condition for the success of the utility computing paradigm. So here user convenience is a major advantages of the virtual machine architecture. So user convenience, it is a major advantage we can say of a virtual machine architecture over a traditional operating system. For example, so we have a user of the AWS. So AWS concept already we have gone through, that is Amazon Web Services could submit an Amazon machine image, could submit an Amazon which can submit Amazon machine image containing the applications, libraries, data, and associated configuration settings. So this is all about user convenience. The next is side effect of virtualization. So there are some side effects as well. So we can see what are those. There are side effects of virtualization, notably the first one, performance penalty and the hardware cost. So how these we can say that the side effect of the virtualization. So here, all privileged operations of virtual machine must be trapped and validated by the virtual machine monitor. So this all everything has to be trapped and monitored by the virtual machine monitor. which ultimately controls the system behavior. So this virtual machine monitor, which completely like monitor as well as control the system behavior. System behavior. The increased overhead has a negative impact on the performance. When there is a overhead in the system, that of course will be directly proportional to the performance. What happens if the increased overhead has a negative impact on the performance? Then what happens? Then the performance penalty occurs. So the cost of the hardware for a virtual machine is higher than the cost of a system that running under a traditional operating system. So when you come to the cost, the hardware cost for the like virtualization, so it will be more compared to the traditional operating system. So here, and it is typically configured with a faster or a multi-core processor and which require more memory. So when it require more memory, of course, the cost will be increased. The cost will be increased. Then it required larger disk and additional network interfaces compared with the system running a traditional operating system. So because we are using more memory, because we are using the larger disk, and because we are using the additional network interfaces, additional network interfaces, so this leads to the cost will be increased. This leads to the more cost. So these all are some of the side effect of the what virtualization. So hope you have understood the concept, what is mean by virtualization and the motivation of the virtualization. Thank you so much for patience listening. Please like the video, subscribe the channel and share the video. Thank you so much.